Today, we are going to look at how to make an LED blink with an Arduino. For this, you will need an Arduino, a breadboard, one LED, one resistor, and two jumper wires. In this video, we are using an Arduino Nano, as it can be mounted on a breadboard. A breadboard is a way of constructing circuits without having to use a soldering iron. Components are pushed into the sockets on the breadboard, and then jumper wires are used to make connections. The middle section of the breadboard has two columns. Each column is divided up into rows. Each row has 5 holes that are joined together, so that anything pushed into one of the holes is connected. On either edge of the board, there are 2 columns of holes marked by the blue and red lines. These are normally used as power rails. The blue rails are for negative, and red for positive. Using an LED, a current-limiting resistor is needed, or the LED could blow and release the magic smoke. To work out the value of the resistor, we will need to use something called Ohm's law. A simple formula is used to show the relationship between current, voltage, and resistance. The formula we need to use is resistor equals voltage divided by current. To use this formula we need to know the Arduino's supply voltage, which is 5 volts, and the LED's forward voltage, which is 2 volts, and forward current, which is 20 milliamps. Now we know these values, we can calculate the needed value of resistor. Resistor equals 5 volts minus 2 volts divided by 0.02 amps, which equals 150 ohms. This is the minimum value of resistor needed. We will be using a 240 ohms resistor. Check the values for the LED you are using, as they may be different. We can now start assembling the circuit on the breadboard, starting by placing the Arduino Nano on the board. Next, we will look at the LED, which stands for light-emitting diode. A diode essentially acts as a one-way valve for current, which means we need to place the LED the right way round in the circuit or it won't work. The positive leg of the LED is longer than the negative. This is called the anode. The negative leg is called the cathode. This is indicated by the flat edge on the LED outer casing. Place the negative leg of the LED into the negative rail on the breadboard, and the positive into one of the rows. Now insert one leg of the resistor into the same row as the positive leg of the LED, and the other into a free row. Now take a black jumper wire, and connect one end to one of the ground pins of the Arduino, and the other end into the same negative rail as the LED. Now take a jumper wire, and connect one end into the same row as the resistor, and the other end into the same row as pin 7 of the Arduino. With all the parts in place, it's time to look at the code. First, start up the Arduino IDE software. With a new sketch open, you will see there are 2 parts to it. The first section of the sketch is the setup function. This is used to initialize variables, pin modes, or anything else that needs to run on startup. The setup function only runs once, after the power is turned on or the Arduino is reset. Next is the loop function. This does what its name suggests, loops repeatedly. This is where we put our main code, which will run over and over again until power is removed from the Arduino. To start with, we need to give the pin we will be using a variable. A variable is a place for storing a piece of data. It has a name, a type, and a value. To do this we type int LED pin equals 7 semicolon. Now we can move to the setup section, so we can set the mode of LED pin. To do this we need to type pin mode, open bracket, LED pin, followed by a comma. Now for the pin mode, which is output. To finish this line, we type close bracket, followed by a semicolon. Each line of code must end with a semicolon, or the code won't work. With the setup done, we can now move on to the loop. To make the LED flash, we need to turn pin 7 on and off. This is done by setting the pin high and low. High turns the pin on, and low turns the pin off. This is done with digital write. First, we need to set pin 7 high to turn the LED on. Type the following. Digital write. Open bracket. LED pin. Comma. High. close bracket, semicolon. Now we need to use a delay. This is to set the time we want to keep the LED on for. This will pause the program until the specified time has run down. Type the following. Delay. Open bracket. 1000. Close bracket. Semicolon. 1000 is the time in milliseconds we want to keep the LED on for. Now we need to set LED pin 7 low, to turn the LED off. Copy the first digital right line, and change high to low. Now we need to add another delay. With the code finished, it's time to upload it to the Arduino. Plug in a USB cable into the Arduino. Now on the Arduino IDE menu, go to Tools, then Board, and select the Arduino you are using. Now go back to the Tools menu, and select Port, then pick the COM port your Arduino is on. Now we can press the Upload button. As you can see, we have an error in the code. This is because we forgot to give mode a capital M. Once we correct pin mode, we are ready to try uploading the code again. It should only take a few seconds for our sketch to be uploaded to the Arduino. Now that everything is working, we can edit the delay time to make the LED flash faster or slower. Changing the delay to 500 milliseconds, the LED will flash faster. Thanks for watching. If you found this video helpful, maybe hit the like button, and consider subscribing to see more.